All right, good evening again, everybody. Recording started. Um, we are done with module 5. So module 5 was short and sweet, I hope, because it was a lot of stuff revisited about the conditional, and we built on top of that. What we're going to do on module 6 is going to be some stuff that we haven't seen actually in module 1, 2, or 3, with the exception of talking a little bit about the chart data type, which we already did. We already got started on that. Okay. So we are going to move into module 6, and please, if you have like logistical question, like for example deadline, exam content, stuff like that, please hang on to them until the end of the lecture when we start office hour, and I promise you I'll answer everything then. Okay. So jumping into module 6. So module 6 should take us a week, so 2 sessions maximum, all right? So it's going to be also a short module. The purpose of module 6 is to discuss a bunch of methods that are useful. So we've been already using a bunch of JDK method, okay, anything from system.app, println, to learning how to use a scanner. So we are a part of learning how to program in a language is also learning how to use all of the methods that come already with the language, with the base standard library, and then eventually all the methods that come with third-party libraries that you install. For example, if you want to do web development, you're going to install a specific library. You're going to learn to call the method from that library and also learn to create objects from that library and stuff like that. We'll talk more about all of that in COP2513, but for now, what we want to do is we want to keep exploring more useful methods from the JDK that we installed. So the problem with this kind of topic is that it can really turn easily into a catalog. So I'll do my best, to illustrate how to use the stuff that we discuss about, so that it makes it a little bit more interactive. But it's true, if you take a look at the reading assignment that corresponds to this lecture, this module, it's going to be a lot of information, but it's a lot of information that you don't necessarily have to memorize by heart. What you need to know, for example, is, oh yeah, there is a way to convert a string that contains a number into an actually int value that represents that number, if it's an integer, right? So you need to remember that, and then remember what the name of the method is. And if you remember this, then as you need the method, you can look up real quick in the textbook, the syntax, the documentation, what parameter it takes, what it returns. And if you do that a few times during the practice exercise, then you are going to have all of this information pretty much already memorized without problem. So you don't have to sit down and memorize by heart, forcing it like that. You just have to use them a lot. And CodingBat is going to do a great job at making you practice actually the strings. So more about that when we get to strings, right? For this module, the reading assignment will be chapter 4. Again, it's not optional. I put that on every module, right? Remember, the lecture and the reading assignment kind of supplement one another, and the quiz are going to make sure that you didn't miss anything important in both. In addition to chapter 4, we have also Appendix B. So again, the Ascii table, not something that I want you to memorize, but I just want you to know where it is in the textbook, know how to find it, know how to use it. And if you ever need, to make long characters, which you might expect, at one of the upcoming intermediary exam, for example, then you will be able to get easily, for example, the index value of the character lowercase a. You don't have to know that. You just have to look it up, okay? As far as activities in this module, we are going to have practice exercise. As usual, they are in the slides. A practice quiz, it's already released. Don't wait, start using it today. Graded quiz, which will be due at the end of the module, and graded exercise, which are also due at the end of the module. But you know how the graded exercise work. Every time I run the grading script, right, if you complete any work on any of the previously assigned graded exercise, you will get credit. So the deadlines are like the most flexible that they can be, pretty much. But if you want to reap the full benefits, you have to actually, do them as we cover the material. So question about the deadline. So please keep in mind, question about logistics, save them for the office hours, please. But the deadline should be already in Canvas, okay? So just make sure to look at the syllabus section. It's actually the best spot to see and keep track of all your deadline for the course. Practice exercise. Again, I'm going to assign a few practice exercises from the textbook. Work on them as early as possible, as soon as we cover the material that you need to make progress in them, right? And the section number is going to help you figure out, whether we covered that material or not in our 2 lectures, and ask for help as usual. Come to the TA office hours. A lot of you are coming to office hours. That's great. Okay, keep doing that. It's exactly what you need to do. And graded exercise coding bat. So there we go. The links are here. The links are also in Canvas. Somebody reported a problem in one of the previous links. I'll look into that. But any time there is a problem, just let me know on Piazza, and I will look into it. Okay. All right. So now we can get started. So the full title of the module was something like method for math, character, and string. So we're going to talk about the math methods first, and this is going to be probably the most catalog-like, part of the lecture. So please bear with me. It's a lot of, oh, this exists, that exists. Just keep that in mind, okay? So first thing we're going to talk about is some constants. So you remember how we define a constant in Java, right? It's pretty easy. It's actually a constant is a variable that has a keyword final in front of it. So for example, if I define, let's go and grab that. I define int value equal 42, then I can modify value. If I define another variable of type also int named value constant, okay, then that one cannot be modified after a while. So it's traditional. It's a convention to name your constant with uppercase letter. And if you do that, the camel case doesn't really work at all, right? So if you have multiple words in the name of the constant, you separate them by underscore. All of this, we already talked about it. Well, that convention is used also, of course, in some classes like the class math. So we have been encountering math before. We did math.sqrt for square root. We've seen math.pow, power, to elevate x to the power y, something like that. But this slide is just letting you know that the constant e and pi and a bunch of other constants actually are available in the math library as well. So if you ever need to look them up, just look up the documentation math class, and you're going to see everything that's in the math class, and you're going to spot those constants because they are like all declared and named in uppercase letters, okay? And I put a link here to a page that does actually a good job at summarizing most of what we are going to talk about in this first section. So I kind of diverge from the textbook a little bit to just, skim over and give you the intro on each of those features. Trigonometric method, who doesn't like a little bit of trigonometry once in a while, right? So they're going to work just like power and square root, right? You type math dot, and then the name of the method, parentheses, the parameters. So let's take a look at what we have. We have all the usual suspects, sinus, cosinus. Question in the chat, is there an inverse square root in math? I don't know. I honestly don't know because I haven't had use for it probably in decades. So we'll have to look it up in the library, okay? There are a ton of methods in the math library. I'm not just showing all of them here. I'm just sampling, a few categories to give you an idea of what you can find. So here we have all the usual suspects, sinus, cosinus, tangent. There's probably arctangent, arccosinus, etc. in there as well. The only thing that's really important when you use trigonometric method in Java is to remember that the trigonometric method in Java work in radians. So that means that we have also methods here to convert to radians. So you give a value in degree, it returns the same angle in a radian, or 2 degrees, you give value in radian, you get back a result in degrees, okay? So this is a very common mistake. You call math.cosinus of 360. That's not going to do exactly what you think it's going to do, okay? So make sure to always convert to radians when you are using the math trigonometric library. And then what else do we have here? We have, so trigonometry, that's one thing. Exponential method. So we talked already about one, and this is the one that we're going to use most likely in this course. Okay, we're not going to do very complicated math things in this course, but so there is the power here. This is the one we already talked about. Give me 2 double values, and I will return you the result of elevating the first double value to the power of the second double value, and the result is also a double. Okay, so this one is very intuitive. Exponent returns e to the power, the constant e to the power whatever parameter you passed, okay? Then we have the logarithm base e, logarithm base 10. So again, it's just a matter of knowing that these things are there and available when you need them. And then the grabble bag of methods, miscellaneous, right? So the square root, absolute value. So absolute value is interesting because most of the method here, when I put the summary like that on the slide, I said it returns a double, it returns a float, maybe it returns, whatever. Here, we say it returns t. So t is not a data type, it's just a notation I use in the slide to mean what is explained here. What is explained here is when you pass a parameter x to the absolute value method, math.apps, okay? The data type of the parameter is going to determine the data type of the value that is returned. So if you pass an int, you're going to get an int back. If you pass a long, a float, a double, a double. So that's kind of new, okay? That means that there are methods that have multiple variants defined and that are going to return to us, not different values, but different data type of the same value, depending on what we gave to it. So again, remember in programming, it's not only the values that matter, it's the value plus the data type. So when you use the math.abs method, you need to be aware of that quirky behavior. It's really useful, but you have to be aware of it. Math.max, math.min, they work exactly the same way. Okay, so as the name suggests, max takes two parameters and is going to return the value of whichever parameter was the biggest. Min is going to do the other way around. And again, the data type of x and y is going to determine the return values data type. If you put x as an int and y as a long, I'm assuming there's going to be some sort of implicit typecasting to put them back to the same data type using the largest one, and then you're going to get that data type as a response as well. But we can play with that to double check it later. Rounding method, these are going to be hands down the most often used DOS, and the next one in the next slide, which is a random method. So we're not going to do a lot of trigonometry in this class. That's a guarantee. But we are going to sometime have to round up, round down, and stuff like that. So there's a bunch of methods actually that help us doing round up, round down. Let's start by the bottom. The bottom one is the math.round method. And this one has two variants. One that takes actually a parameter of type double. And if you give me a parameter of type double, then I will return to you long. Okay? You give me the largest floating point data type, I return to you a rounding of that value expressed in the largest integer data type. Okay? And the rounding is exactly what you would think rounding does. What I mean by that is that you round up to the nearest integer. Okay? So that's math.round version 1. Math.round version 2 works exactly the same way. You give me a floating point number, I return to you an integer, but this time the data type of the floating point number will be float, which is smaller than double, and the value returned will therefore be of data type int, which is smaller than long. But the full rounding mechanism is the same. I return the value that is the closest, the integer value that is the closest to your number. Okay? What about the other ones then? So math.floor, math.ceiling, abbreviated ceil. So those are going to return to you double values. So you are not rounding and converting the data type. Okay, this is what math.round does. Give me a floating point, I'll give you an integer. Now here, you give me a floating point value, and I will give you back another floating point value. But I rounded that floating point value. So what does that mean? What does that mean, integer value double? Question in the chat. Okay, I'm going to explain that in a minute. So you give me a float, and I'm going to return you a double, but that double will represent actually an integer value. So for example, if you give me 13.9, okay, I'm going to return to you 13.0 when you call floor. Why did I choose to return 13.0 and not 14.0? Because floor rounds down. Okay, easy to remember. Floor is at the bottom all right? But that's what it means, integer valued double. It means that I still return something of data type double, but it's going to represent an integer value. So you effectively, you got rid of everything after the decimal, but unlike the truncation that we've seen before, you know, messing around with data type and converting from a double to an int, and we lose all of the digits after the decimal dot, right? This one is actually rounding always down, okay? So that means that we have also another method, and like Amit guessed in chat, that one is going to round up, okay? So that one is not going to just get rid of the digits after the decimal dot and return to use the integer part. It's going to actually round up the integer part. So if I give you 13.5, you are going to return 14.0. If I give you 13.9, you're going to return 13.0, 14.0, okay? So yeah, you got it, Tristan. So it's not complicated, all right, but there is a little thing that I do every semester just to make sure everybody is on board, and we're going to do that relatively quickly, if I can find it. There we go. All right, so what we want to do here is we want to check out all of those methods. And one way to check out new method when you are learning them is to try to apply them. You don't have to write a big program to try on those methods. You just have to have a simple main method in an empty class, okay? And you are going to call math.floor, math.ceiling, math.round, and math.rint, which actually I forgot to mention. So let me go back to the slide real quick, and let me mention the last one here that was forgotten in the middle. There is yet another rounding method here, rint, and this one is going to return the closest integer value double to d. So it works like floor and ceiling insofar that you give a floating point number, a double, and it returns a double as well, okay? But this time, if I give you 13.9, you're going to return 14.0 because it's the closest. If I give you 13.1, you're going to return 13.0, all right? So that's, okay, now I covered all of the method that were on the slide. We can jump back to the code real quick. And I'm going to show you, it's not really important what this program is going to do. It's just what I want to show you is the idea of, I learned something new, I want to tinker with it, how easy it is, how simple it is. You don't have to write big programs to really make sure you fully understand, you know, what's going on here. So what we're going to do here, we're going to do a bunch of system.out.println, okay? So system.out.println, there we go, system.out.println. And I'm going to display the result of, for example, math.floor, and I'm going to put an arbitrary piece of data, like 3.0, okay? So I just want to see what this is doing. There we go, build, run. There we go. So floor, remember floor at the bottom, no problem. 3.0, this is exactly what I expected, okay? And then I want to play a little with the values. So I'm going to do math.floor. And what happens if I give, for example, 3.1? What happens if I give, and I'm going to put like a space in between each of those, okay? What happens if I give, let's indent this so that it's easier on the eyes. There we go. What happens if I give math.floor 3.1? What if it's math.floor 3.9, okay? And then the last, I mean, we are applying the same mindset that we do when we test, okay? I want to exactly figure out, you know, what makes this method tick. So I'm going to try to kind of take the edge case, the cases that are not necessarily trivial. So is 3.5, you know, closer to 4 or closer to 3? So I use this to test the behavior of the math.floor method and figure out exactly how it works. So let's take a look. What we have here is so let's make sure this makes sense, right? 3.0 is floored to 3.0, 3.1, yeah, 3.9 as well, 3.5 doesn't matter. So for the floor method, no matter what you have in the range, there you go, you got it. It's not going to matter, okay? You're still rounding down, I mean. And then we are going to do the same thing, and we are going to look at the next method, which was ceiling. So there we go. I'm going to replace that. Same as a method everywhere. Build again. We're going to compare. So The first one was 3.0. Doesn't make a difference, right? 3.0, you try to hit the ceiling, you are at 3.0 already. The roundup to the next integer is 3.0 itself, integer value, I should say. Then what about 3.1? That's enough. You have like a 0.0001 above 3, you go immediately to 4. 3.9, you go to 4. 3.5, you go to 4. So the opposite of the previous one. But please note that ceiling of 3.0 is still 3.0. Question from Felipe: how do you select the word like that without using the mouse? I cannot reveal that secret. No, I'm just kidding. So you can double click on a word, that would work. Otherwise, you can go here and do Control Shift right arrow, and that will select actually the entire word like this. All right, so that's for seating. Yep, no problem, anytime. Now the next one we're going to look at, let's look at rint. Okay, rint is going to be actually, I think, the most interesting of the lot. So let's see, here we go. All right, and now I'm going to build. So remember, rint is going to return to me a double value as well. Okay, all of those methods return a double value, but it's supposed to be the closest. So 3.0 is closest to 3, yeah. 3.1 is closest to 3, makes sense. 3.9 is closest to 4, and then 3.5, we're going to 4. So now I could play a little bit more with that and try to figure out exactly when we make the shift, you know, to 4.0 as rounding up. I mean, this is the kind of stuff that keeps me up at night, right? So if I have 3.4, you know, how is it going to be round up? So let's try. It goes down to 3.0. So that makes me curious. And now I'm saying, okay, so how close do I have to be to 3.5 to be taken back to 4.0 as round up? Well, okay, as long as I am in 3.4 something, like 9999, etc., up to 9999, then I'm going to be dragged back to 3.0. Otherwise, I go back up to 4.0. Okay, this is a kind of playing that you do to figure out really how to use those methods, right? And then we have only two of them left. And the two of them left are both the round method, okay? So I'm going to go ahead and use round here. There we go. We are going to keep all the tests that we had for the previous one. Just curious to see how this is going to work out, right? Build, run it. So round, like the last two methods we have to cover, remember they return an int. Okay, actually they return an integer, meaning either a long or an int. In this case, what is the default data type of a double literal? It's okay, when it's phrased like that, it's an easy question. What is the default data type in Java of a floating point number literal? It's double. So I pass a double, that means this is going to return a long. There we go, these are the value, 3, 3, 4, 4, 3. Okay, so it's doing the same thing, but now it's returning an int value. And what if I do the last one? So the last one is still the round method, so I'm not going to have to rewrite anything here, but it's a round method that works on a floating point parameter. How do I specify that the floating point literal is of data type float instead of double? I have to mark it. Yep, exactly, Felipe. I have to mark it with an F, or like River said, could be an uppercase F, okay, doesn't matter, but you have to add this letter, okay? So now all of those literals are going to be seen by the Java compiler as float data type. And when the Java compiler is trying to call the round method, it's a very important mechanism. We're going to talk about it a lot in COP2512, okay? But right now, this is our first encounter with this mechanism. What do you do when you have several methods that have the same name? How do you know which one to execute? Well, we look at the data type of the parameter, and that gives us a hint, right? So data type of the parameter is float. I'm going to use that version. Data type is double. I'm going to use that other version, okay? So yes, I can scroll up, Andrew. Here we go. So, and I'm going to upload this code to Canvas once we're done, all right? So no worries. So now what I'm doing is I'm calling the same round, different variant of the same round method, and I'm passing a bunch of floats. Let's compile this. Let's run it. And so it's going to behave a little differently here, okay? And I'm guessing this is because I put way too many digits here. So let me try to do something like this, okay? But other than that, the first numbers were exactly the same. So let me build it and run it again to see if that was a problem here. There we go. Now it's fine, okay? So what was wrong here is that I wrote a float. It was supposed to be a float literal, but I put too many significant digits. I went overboard, so it was not taken as a float literal. Okay, so that just shows you that most of the time you really want, at least in this class, to use double. Okay, so that you don't have to worry as much about the limitation of data type, but you have to be aware of those limitations when something weird like this happens. All right, I think that's all of them, right? Yes, so that's all of them. So these we are going to use semi-frequently, okay? It's more common to use these in COP2512, 2513, and even up to data structure than to use, for example, the trigonometric methods, all right? The last method that we're going to talk about from the math library is math.random. And we already talked about it. I introduced it first time as a pattern. I told you pretty much this recipe, you know? You do math.random, that gives you a number between 0.0 and 1.0 not included. Okay, so 0.0 included, 1.0 not included. So you can have anything like, for example, 0.99999998653. Okay, that would be a value returned by math random. So math random doesn't know about ranges. You know, I want a number between 1 and 6. Math random cares not. Math random is just going to give you always a floating point, random value between 0 and 1, not included. So what you can do is you can just apply some basic arithmetic to scale that up to whatever you need. Okay, so if you need, for example, a number that can go between 0 to 10, not included, yeah, you're just going to multiply by 10. If you want a number that goes between 0 to 6, not included, so 0, 1, 2, 3, 4, 5, point, blah, 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 you multiply by 6, okay, and so on and so forth. So multiplying by a certain factor is going to allow you to scale the range of your random numbers. But we still get floating point values, okay, first remark. And second remark, we still get numbers, random numbers, that start at 0. So to change that, we can add a term, okay? So for example, if I say 1 plus math.random times 10, it's going to give me, so math.random gives me a number between 0.0 and 1.0, okay? Always not included, the end part of the range. Multiply that by 10, so I get from 0 to 10, okay? 0.0 to 10.0. Add 1, now I get from 1.0 up to 11.0, not included. Okay, so we change the scale, we shift the scale, we scale first, and then we shift the beginning of the scale depending on what we need. So two simple operation. But this is just like the general ID. Okay, this is actually what you need to actually code in your programs. What is the difference between the two data types? Here we explain the general ID, multiply to scale, add to shift, okay? And here we take care also of transforming those random floating point numbers in, for example, random integer numbers. So let's take a quick look. This is going to be easy again, but let's take a quick look at how we can mess around with that random here. There we go. So I'm going to do that right after. It doesn't matter. I'm not going to make a method for this. So what I want to do is I want to show you like the common mistakes, okay, that we can do with this. Do I have a variable value of type int? I do. So I'm going to use it. All right, there we go. There we go. So value equal, and I want to just put a random value inside of this. So math.random, okay, I call the method, multiply by 10, add 1, okay? And I'm going to display this, system.out.println value. And we're going to see what we get, okay? Get an error, which tells us incompatible type, possible low-ceil conversion from double to, I need to say int. There we go. So it even tells you when the conversion is potentially problematic, right when the plus is encountered. So what's going on here? Well, this is going to be, this here, math.random, is going to return a double. What happens when you multiply a double by an int? The result of the multiplication is of data type double. What happens when you add an int to a double? The result of the operation is a double. What happens when you try to assign a double value to an int variable? This. The compiler tells you, I'm not touching that with a 10-foot pole. Okay, that's it. So this is the same problem that we encountered when I first introduced data types. Okay, we are trying to assign to variable, values like doubles inside an int variable. The compiler says, I'm not going to have any of that. So that means that here, at some point, we need to convert to int. So let's go ahead and do what could be, a first natural reflex, which is let's convert. Let's put our int conversion like that at the beginning of math.random. And then we're going to build. Compiler is happy. That's a good thing. We're going to run it. So my random number is the last thing that's displayed, right? 1. Okay, we're going to run it again. 1. Oh, wow. What are the odds, right? 1, 1, 1, 1. So this is starting to get weird. My random number between 1 and 10 is always 1. So it's either we are very unlucky or we are bad programmers. In this case, I was a bad programmer. Can you guys tell me what was wrong with what I wrote? Do you see it? Parentheses, yeah. So bad parentheses, exactly. So what's happening here is math.random, remember, it always returns a random number between 0.0000 and 1.0 not included, okay? All right, so what happens when you convert such a number to an int? It's going to always be 0, because that number is going to be 0 dot something something, all right? And that something something is going to be truncated, so we always get a 0. Then we multiply dutifully 0 by 10, which gives us 0, and add 1 to it, which gives us 1. Okay, so this is not really what we want. What we wanted to do is first multiply math.random, the result of math.random, right, by 10. So that's going to give us a number between 0.0 and 10.0 not included. So we still have decimals and stuff like that. And then convert that to an int. So that's going to give us a number between 0 and 9. An integer value between 0 and 9, I should say. Okay? So again, it's what is the problem here? Precedence. The operator precedence. What is the priority of the multiplication operator compared to the typecasting operator? When you use those parentheses with a data type name in the middle, it's also an operator. It's typecasting, and you can put it in expression, and it has a precedence, and it has an associativity. Either you remember by heart the precedence and associativity table, or you have been programming every day of the week for like the last 10 years, and you know that like the back of your hand, or you are not sure. Again, if you're not sure, what do? You over-parenthesize. And then as you use this more and more, you're going to get used to seeing that. You're going to know exactly when the parentheses are useful and when they're not by, testing out and trying out pretty much. So now that we have this, so question in the chat from Andrew is no number between 1 and 11. No, it's going to be between 1 and 10. So I got 9, 1, 3, 7, 2, 5, 3, and we can keep like that for a while, okay? It's going to be between 1 and 10. Why? Because this is between 0 and 10, 0 and 1 not included. So that means that this here is between 0 and 10 not included as a floating point. This converts it to an int. So 0 to 10 not included as an int. That we could say 0 to 10 not included, but it's really 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are only those 10 possible value. I add 1 to that. That is between 1 and 10. Okay, included. All right. So that's pretty much all there is that can be remotely tricky with that random operator. But now we had the opportunity to kind of like finish up and explain completely, everything that there is to know right now about this thing. So that was half deja vu, well, more than half, 90% deja vu, and then 10% maybe like rounding up the explanation, something like that. So now we are done with the math library. Let's take a look at the char primitive data type. And we're not going to only look at the char primitive data type because we did that already, but we're going to also look at the character with an uppercase C class. So it's going to introduce to us, that notion that every of the primitive data types in Java, so int, long, char, float, double, and I forgot some bytes, Boolean. Each of those primitive data types that are spelled all lowercase, they have a class counterpart. Okay, so math is the name of a class, uppercase M. Well, character with an uppercase C is a class name that corresponds to char. Okay, why did they use character instead of using char with an uppercase C? Not sure. Okay, but all the other data type are like that as well. For example, int correspond to the class integer, double correspond to the class double. So double is really easy to remember. Int integer, okay, you have to watch out. Char character, but every of those data type has a class that's going to be its counterpart in the world of object-oriented programming. And what they provide to us, and we can already start using in this class, even though we don't touch really object-oriented programming until COP2512, what they provide us that we can start playing with right away is a bunch of methods that operate on that data type. So this is what we're going to look at, okay? Quick reminder, we're going to do a reminder plus, okay? So stuff that we have already seen plus something new. So we have already seen how to declare a variable of type char. So I'm talking about the primitive data type now. So char letter, char numchar, char letter, char numchar. Okay, these are like declaration. And we saw that, a single character literal is written in Java using single quote. So you put single quote around one character. And when I introduced that notation, I told you it's one character, it's a single character between single quotes, okay? Internally, this is represented as a number. Now that we know all about bases, right, we can say that the letter uppercase A is represented internally as the number 65 expressed in decimal. If we were looking actually at the bits of memory, that number 65 is encoded using binary. So we would see, something like this. Actually, I think that's an accurate value if I did my job well. And then if we were looking at the memory content, with a tool that would show us packs of 4 bits as an hexadecimal digit, then we would see something like this, okay? So get used to that when people are talking about representation of values in memory. They don't necessarily use decimal. They rarely use binary, but generally they look at hexadecimal, okay? What else? That rule about one character, what's happening here? What the hell is this? So there are 1, 2, 3, 4, 5, 6 characters between the single quotes. So how does that work exactly? If I write in my compiler, so let me grab JGrass real quick. If I go here and I say in my program, char letter equals A. Oops, international keyboard going on here. There we go. So char letter equal A. The compiler has no problem with that. If I do char letter equal hello, the compiler has a lot of problems, okay? But these are all related to the same line. It says error unclosed character literal, which means after the H here, I expected you to close with a single quote that character literal. You didn't close it, okay? And that triggers all the errors that come after. So we cannot have multiple character yet. In the slide, and I don't remember the number, we had backslash U, there you go, 0041, okay? So that is, like I said, multiple character, but it compiles, okay? Not only it compiles, but if I want to use it, system.out.println, the weird character is, and then I'm going to concatenate at the end of that what's in letter. So by the way, implicit typecasting here, right? You add a string, a whole string to one letter, the letter get converted to a string, the two string gets concatenated, sorry. So what happens if I try to display the string? So let's scroll back up. The weird character is A. So wait a minute. So what we have here is a weird encoding for the same character A that we have there. And what we have here is a weird encoding for the same character 4 that we have there. So that way of encoding character, if you pay attention, okay, you're going to notice that it uses actually an hexadecimal notation. One more reason for which hexadecimal, tends to come up as a topic very often, all right? So when you try to write characters using that special code, you're going to have 4 digits here that are hexadecimal digits. And if you look at the numbers, the index, in the Ascii table of the letter A, well, that index is going to be the last 2 digits of that number. So what is this code? This is a Unicode. Most of you probably heard about this, okay? So the Unicode is backward compatible with the Ascii table. I always introduce the Ascii table, and the textbook does the same. I think most people do because it's very easy. It has only a few characters. It's not pages and pages of character tables, but it gets the idea of my characters are represented in a table, right? And I use the index to refer to them. Well, Unicode is the same thing, but we have a larger table. But that larger table is built so that for the first indexes in that table are totally backward compatible with the Ascii table. So that made things a little easier. For example, character 0 to 9, this is their code value in decimal, and this is a value that we use in the Ascii table. This is their code value in hexadecimal using the Unicode value. So when you want to specify a character with just the letter, you put single quote the letter. When you want to specify it with a decimal value, you would put char letter equal 65, just a number. If you want to specify it using the Unicode, then you are going to put single quotes like a character literal, but you are going to prefix the number, the 4-digit hexadecimal number, by \u. And \u, of course, the U stands for Unicode. So when the compiler sees a single character literal that has multiple characters, it checks first that it starts with \u. If it starts with \u, okay, I'm going to let it roll because I know that you need to give me 4 hexadecimal digits. So I allow you to give me more character here. But if not, then that's an error. Okay, like the word hello, like you saw me try sooner, it's not going to work out. So we have this alternative code, the Unicode, and to be honest, everybody uses the Unicode right now. We have this alternative code, and this alternative code uses actually 16-bit. Okay, so 4 bits per hexadecimal digit, right? So 4, 4, 4, 4, that's 16. The Ascii scheme, the Ascii table, used only 8 bits. So what's the advantage of using 16 bits instead of 8 bits? You can store more values. Why would you need to store more characters on a table like this one? Well, as long as you are just using the Latin letters, the basic letters, that's okay. As soon as you want to do things like Greek letters, you get into trouble with the Ascii table, right? So there was an extended version of the Ascii table. I think that went up to 256, something like that. But again, nowadays, everybody adopted the Unicode because that Unicode allows us to encode like 65,000 plus values, right? So that means that pretty much we can encode any character from any alphabet of any human language, that was developed on this rock, okay? So that's it. Unicode has become pretty much de facto standard. It's backward compatible with Ascii, and the logic is the same. It's just that if you want to address, the Unicode indexes, generally you'll have to use hexadecimal notation. If you do operation on that, watch out, you are in hexadecimal base, and so on and so forth, okay? Another thing, so that we didn't really talk about it, okay? We just talked about Ascii table. Okay, so that's one thing added to what we saw before. And now, second thing added to what we saw before, you remember when I showed you that Ascii table, I told you there are letters, uppercase and lowercase, there are numbers, and then there are even control characters, special characters. And I didn't say much about them. I think I mentioned the new line character, something like that. But here's the deal. What if I want to actually do a system.out println, And I want to tell the system.out.println that I want actually to go to the next line. So println already does it, okay? So let's take maybe a better example. Let's try to do a system.out print, okay? Like for example here, there we go. The weird character is letter. If I do just a print, well, the rest of the stuff being displayed on the screen is going to come at the end of the line here, okay? Is there a way for me, since there is a special control character that means new line, is there a way for me to write single character literal here that's going to mean new line? Yes, there is. But either you give its code, right? Or you use its Unicode code, or you use the abbreviation \n. So you will often see in strings and in single character literals, you will see things like this, / something. So the same way that \u, okay, means, you know, I'm about to give you a Unicode, \n means that, no, I didn't mean, you know, the character \n. I meant the special character \n. So / has a very special meaning in strings and in character constants, literals, okay? So \n means new line. If I run this, I'm still using print, okay, not println. But if I run this, there you go. After the A, you know, I went to the new line. And I can insert those even in strings. So if I put \n in a string, when the string is actually parsed, Java understands that \n doesn't mean you want to display / followed by n. No, that means \n, special character, new line, okay? So it's going to introduce a new line when displaying the message. The weird new line, space character is a new line, okay? So the ones that we are going to use the most often, I would say, are the new line and the tabulation. Tabulation means horizontal tabulation. That means what would happen in a text editor if you hit the tab key. Okay, the tab key stands for tabulation, and it's going to push actually the rest of the message towards the right by a certain number of characters. So there are settings in terminals and stuff like that, and editors even. Generally, a tabulation is estimated to be roughly 4 characters. Okay, so we're not going to be like too picky with that for our first examples. But here's what's happening. The weird space, so there's a space here, okay? There's a space here, but then there is a tabulation. So the tabulation makes us, actually, I kind of misrepresented the tabulation. Sorry about that. The tabulation doesn't always make you jump by 4 characters. It makes you jump to the next 4 character mark. What do I mean by that? So imagine that this is your terminal, right? Each dot represents a character on the screen. All right, so this is going to be, for example, index 0, right? This is a character at index 0, then 1, 2, 3, 4. So the concept of the tabulation is that, there we go, is that we have predefined tabulations, mark, okay? And all this comes from typewriters and stuff like that, okay? We have predefined marks along our line of text. So for example, every 4 characters, so that would be 5, 6, 7, 8, every 4 character, I have a tabulation mark, okay? 9, 10, 11, 12. So 12 is going to be causing problem here, but anyway. All right, so I have this right now. This is by default in my terminal. So when I write something, like for example, AB, okay, it's going to take 2 characters. If I put a space CD, there we go. This is how it's going to fit on the screen. What if I display something like, so we're going to write it here as a comment, okay? What if I want to display something like AB, and then I want to put a tabulation, and then I put CD? What's going to happen? And I put extra double quote, I don't know why. So if I try to display this, what's going to happen on my screen is that I'm going to have AB. I don't have a space anymore. I have CD after that, but I have a tabulation. The tabulation causes me to jump to the next tabulation mark. Okay, so in this case, I jump 2 characters. Okay, so I'm going to put that on the same line so that when I upload the file, you see what this corresponds to. And I'm going to take a second example. What if I want to display a string that says just A, and then tabulation, PCD? Okay, so how would that work? Well, same thing. I display A first, all right, And then tabulation, so I jump to the tabulation, and then I display BCD. And that's it. Do you guys see how this is working? So this is just a way to neatly align stuff that you want to display. Okay, and I'm going to comment this all, otherwise our code is never going to compile ever again. All right, so this is just a way to do aesthetically pleasing, arranged by column display on a text terminal. And we're going to use that a few times, okay? Not like crazy, but a few times. Question from Felipe. So if you have 7 characters and you backslash T, will you move from 8 to 12? So if you have 7 characters, so 4, 5, 6, 7, you are here. If you backslash T, you move to the next tabulation. So that would be 8 in that case. Okay. So sometimes the tabulation is going to be 1 space. It could be up to 4 space, right? If this is a set size of your tabulation. Sorry. Or it could be even just 0 space if the next character is already the tabulation. Okay. So good question. This is the kind of question that helps you really understand how things work. If you are on 8, for example, so you have a character, you have a bunch of character up to position 8, then if you tab, you're going to jump the full length of the tabulation to tabulation 12. Okay, we are going to see at the end of this lecture, a more complex example of how we can use tabulation and stuff like that. And we're going to see also an alternative way to format stuff on the screen without relying on tabulations. All right, so this is just to remind you of all it's not all of the special character, but it's some of them. And then we have 2 characters here that are not what I refer to as control character. Backslash, backslash, and backslash double quote. What are those doing there? Okay, these are not special control character. These are just a way for us to use the backslash to neutralize the effect of the backslash. What do I mean by that? So again, easiest shown than said. Okay, so let's say that I have a string here. Okay, the weird character is blah blah blah. Okay, I want to put in that string the word weird between double quotes. Okay, I want to say the weird character is the letter and then backslash n, because it's not that weird, right? So I'll put a double quote here. I'll put a double quote here, and you guys can tell already JGrasp is warning me, right? JGrasp is saying, okay, this is a string literal, and you type something. I'm assuming it's an identifier. I'll let the compiler figure out, what variable it is, and then this is another string. So obviously this is not going to work. JGrasp already shows it to us, and indeed, see the deluge of error message. Okay, I expected a closing parenthesis. Why? Why does it expect a closing parenthesis instead of the W? Because when you do system.out_print, you put one thing here. For example, if you have a string literal, and then you close your parenthesis. Here, if I have more stuff, generally I concatenate or do stuff like that. So suggestion from Ethos in the chat, double quotes. Yeah, that would make sense, right? We have to do something when we write our text, okay, that's going to make Java understand that we just want like a double quote. We don't want to close our string. If we put 2 double quotes, it's still closing the string, but look, this is closing the string here, okay? And then I immediately open another string. Here it is. So at least there should not be a syntactical error, right? Yeah, there's still a syntactical error because Java is going to say, why? Why do you put 2 string literal one after the other? If you want me to concatenate them, then say so. So if I add a plus and a plus here, yeah, that will work, right? So now the Java compiler is going to be happy, but when I display, I still don't get the quotes, okay? So what else? Yep, Felipe got it. The logic that some of you might follow at this point is to say, well, I want weird, and then in between, I want a double quote, string. It's still not working, you see? That's not actually accepted. Can I use a single quote then to say just the character double quote? See, if I build that, right, run it, did I get 1 double quote? Yes. So 2 concatenation between separate strings of a single character literal that represents a double quote. Nice. So I hope we're not going to hair quote a lot of stuff because this is going to get weird and boring and tiresome very fast. So there has to be a better way. Yes, there is a better way. The better way is what Felipe is suggesting in the chat, which is, okay, so this is my string. The weird character is, okay? All right, so I'm removing all that junk that I added before. All right, so now what I want to do is I want to insert a double quote. But I want to say, don't interpret the double quote as a special character double quote. That means end of string literal. Every time you have to neutralize the special meaning of a character, if you prefix that special character by backslash, then Java will understand what you mean. Okay, so backslash double quote means don't take double quote as a character double quote. As a matter of fact, don't take backslash itself as a character backslash. It means neutralize double quote. And now you can see that, indeed, even JGrasp, is telling us, yep, this is just one big string. And I can add another one here. So we neutralize a special character. That's what we are doing with the backslash. And when I run this, then it's going to work a lot better, right? At least easier than the previous solution by far. What else? Well, one more thing. What if I want to display system.out.println? Wow, backslash really saved the day. Not exaggerating at all here. I tried to compile this. Illegal escape character, what do you mean? Well, backslash has to be followed by a special character, right, that you want to neutralize. So this time, it said, wow, backslash space? I don't know what that is. So backslash space, you must be confused. So, but I didn't mean backslash to neutralize a special character. I meant backslash is just backslash, right? Give me a bloody backslash on the screen. So Reverse suggested use forward slash instead. Yeah, I can do that, but I mean, this is still not my backslash. I want my backslash, right? So I can display forward slashes all day long, on the screen. Forward slash, sorry, has no special meaning, but backslash has a special meaning, and Java won't budge, from it and not let me insert it like that. If only we had a way to neutralize characters that have a special meaning, right? What did we use to neutralize? There we go. Ethos double backslash. So if I put backslash in a string, backslash is understood by Java as, watch out, the next character is going to be a special character, but I want to neutralize its special meaning. So you are just going to accept it at face value. Okay? So what is the next character after the backslash? A backslash. So I did neutralize the backslash. When I try to display this, there we go. Backslash really saved the day. Okay, so this can come in handy when you have to write things like, for example, C:\\, or HTTP :\, stuff like that. If you just try them like that, well, the C:, there we go. There's a space after the backslash. That's not going to work. So I need to double this. Okay, and then if I run this, the HTTP is still showing only one backslash. Well, yeah, because I kind of neutralized it, right? And I was just double checking because I think that hold on, let me check something real quick. Yes, HTTP is /. I forgot that. So it's a very bad example. Sorry about that. But let's say that I don't remember if it's forward or backslash a slash in HTTP. There you go. I'm trying to write something stupid, and the compiler is preventing me to do so. So I must overcome this limitation, right? So I can indeed write something stupid. So in this case, I would have to say I want 2 backslash, or neutralize the first one, neutralize the second one, and I'm going to be able to get my 2 backslashes on the screen. Okay, so just to not confuse you because of my poor choice of improvised example, okay, HTTP, you want to write it like that. If you want it like that, // is not a special character in Java strings, so that's going to work out of the box. Okay, could you use single quotes? Yes, you could use single quotes like we did here, but again, it's less practical to use single quotes than generally to use that once you get used, to the backslash. And backslash is going to show up in a lot of different things in programming as a way to neutralize the special meaning of something. So it's a good investment for all of you to get used to it by right now. Okay, start getting used to it right now, Jason. Even for you could use the single quote notation there. All right. What else do we have? So at the end of the textbook, in the appendix, you have actually Ascii tables. You have two versions of the Ascii table, but they look nothing like the one that I showed you originally. So it's just the same data. There is just a little trick to interpret them. Quick question in the chat from Andrew about the previous slide. Could we use backslash in place of the negation operator? No. Negation operator is a Boolean operator. Backslash is not an operator. It was used inside of the strings. This is the only place where it has the special meaning, inside of string literal and strings, generally speaking. So this is what the Ascii table that you have in your appendix looks like. So how do you read this? Well, let's say that you pick a character. For example, you pick character uppercase A, which we have been using a bunch of time. The number of the row is going to give you one digit. The number of the column is going to give you another digit. And you put those together and you get the decimal representation of the character A, 65. That's all there is special about it, okay? And then the second appendix, the second table, sorry, that is provided also in the same appendix in the textbook. Again, it's formatted differently, but it has the same content. But this time, it's going to allow you to identify the hexadecimal index of a given character. So how do we do that? Let's say we're talking about the character A again. So there we go. Character A, the row number, digit 4, the column number, digit 1. So this is hexadecimal for 1, okay? So then if you wanted to know what number that represented decimal, you would have to convert it, of course, okay? All right, so there's just this little trick when you read those tables, and I mentioned it because every semester before I did those slides, I had question about how do I read this table. And the worst scenario is when you know that the table is in the appendix, you need it during an exam to know the code of a character for whatever reason, and then you realize it's completely differently formatted, and you start panicking, and you're like, I don't know how to read this table, and so on and so forth. So, okay, it's mentioned in the lecture, that should help. So, equivalence about char data type and numeric data type, that one we mostly covered, okay, like 99%. So remember that you can assign to an int variable, you can assign actually a single character literal. What's going to happen? Implicit typecasting. So it's the same thing as if you wrote int I equal conversion to int of single character A. Single character A, I don't remember the index, 93 maybe, something like that. So this is an index value that's going to be used here and assigned as an int value to your variable I. Char C equal 97, it's the other way around. Now the variable is of type character. You assign to it a small int value, a small positive int value. There's going to be some implicit typecasting again that's going to convert that 97 into, so I guess lowercase, lowercase a is then 96, 95. Okay, so 97 in this case is going to be lowercase, actually that might be lowercase a, we'll have to try it. So lowercase a, we are just doing automatically this kind of conversion here. So it's just like if I wrote char C equal conversion to char of 97. Conversion to char of a small positive integer is actually the character itself, which is assigned to a char value, no problem. So we're mixing in what we said already about the character with the notion of data type casting. Okay, we're tying together two of the things that we already covered. So to make sure that this sinks in, let me take some examples that are more or less trivial. And I'm going to also tie this up with the pre and post increment operators that we have seen before. So take a look at this little piece of code. Char ch equal lowercase a. So a character literal lowercase a. So far, so good. System.println plus plus ch. So plus plus is an arithmetic operator, right? So it's going to do what? It's going to pre-increment the variable ch. Can you pre-increment a variable of data type char? Yes, because really inside of it is a small number. So I can apply the plus plus. I can do arithmetic with char variable. What is this going to display? Then system.out.println ch plus plus, post increment operator. Again, what is that going to display? And then since you told me that I could do arithmetic, with character, at least plus minus, okay? Multiplication, division do not really make sense, but plus minus, yeah. Character H minus character F, parentheses, okay? That means I want to know how far apart those two characters are in terms of the index, right? So if H is, like, for example, index 0, and F is at index 3, well, that would be a bad example. Let's do the other way around, okay? H is at index 3, and F is, let's say, at index 2. 3 minus 2 equal 1, so they are one character apart. All right, so I can do that kind of arithmetic. So what happens if I do H minus F times 4? What's going to be displayed? A character, a number? What is it going to be? So take a look at this code. You can even type it if you want, okay, but that's not really the point of the exercise. But let me know when you think that you know what's going to be displayed, okay? Or even more easily, just type it in chat. BCH. That's the first. Guess, okay? So we're going to let everyone think about it, and either you support that guess or you have another guess of your own. Go for it. So review of typecasting, character representation, and pre-post incrementation operators. Tristan suggested BB for the first two. Yeah. And the third one is a little weird. So we have BCH, BB, and then something else. So it should be BH, actually. Correction to the first guess by Andrew. So this is a good quiz-like question, okay? But again, once you get used to do arithmetic like that on characters, you're going to be able to write some concise code that does some neat stuff. So it's important that you understand it. Plus, this makes you, like I said, review incrementation pre and post. So that's it. Only two guesses. Come on. Let me put back the code. Oops. There we go. Interesting suggestion. BB and then an error. All right, let's look at what this is going to do. So I think everybody agreed, right? The first letter is going to be a B. So why is it a B? Because CH contains A. So pre-incrementation of the variable, what does that mean already? First, you increment the variable by 1. So incrementing the variable CH by 1 means that we go from character lowercase a to character lowercase b. So, and then what do we do with the pre-incrementation? We use that new value. So there we go. This is a new value that is right now in the character variable ch. And then what about ch++? So by the time we reach the second system.out.println, the variable ch contains the letter b, lowercase b. So ch++, the plus is after, so remember post-incrementation. What does that mean, post-incrementation? That means you use the current value of ch, which is b, and then you increment. So I use the current value of ch that is b, so I display another b. And then I increment my variable, which means the variable ch contains c, the character c. But I don't display that, right? And then I do h minus f. So let's look at it part by part, and then we'll figure out if something displays or if there is a compilation error or if there is a runtime error or anything weird. When you do h minus f, what do you get? So the alphabet goes F, G, F, okay? FGF, no, FGH. Yes, I did press the mute button. Thank you for letting me know that. So what I was saying is that we have H and F. Okay, so as the alphabet goes F, G, H, and I messed that up the first time I said it. So we could go to the tables and we could, like look at the index of H, then look at the index of F, deduct the second one from the first one and get the exact number. Or we could just say that, well, okay, since they are like, one letter in the middle, there is a F, there is a H, and there is a G in the middle, then no matter what the index are, the result of that is going to be 2, okay, 2 characters apart. And then 2 times 4. So an int times an int gives me an int, okay? Question from Andrew, it's a question of if we can do b times 4 as an operation. So in that case, it's not going to be b because the h minus f gives you a number, okay? It gives you the number 2. So the difference between 2 characters is going to be a distance between the two in terms of indexes. And then you multiply that by 4 and you get 8. Yeah, so it's 8. There we go. All right. So I think this is, we have like 2 slides left or something like that, but they are easy. What can we do with this notion of arithmetic? We can also compare characters to one another. For example, if you were giving me in a variable a character ch, okay, so ch is the name of the variable, and I want to know if that character is an uppercase letter. If you remember vaguely, the Ascii table, like the lowercase alphabet was here, the uppercase alphabet was there, the digits were there. So digits, lowercase letter, and uppercase letter, they kind of follow each other. They are in order, in the alphabetical order. So if I test if my index for ch is between the index of uppercase A and the index of uppercase Z, if that ch is between A and Z pretty much, then I can say ch is an uppercase letter. Else, if ch is between A and Z lowercase, then I can say it's a lowercase letter. Else, if it's between the character representing 0 and the character representing 9, I can say ch is a numeric character. So I can use that notion of arithmetic to actually be able to compare things. The only remark I had extra on this slide was, by the way, you remember, why aren't we using the curly brace? So yep, that's a review of what we said about that if else, or chained if statement. And then the second thing that we also reviewed was the priority of operators, okay? So why is it that I don't have to put parentheses around ch less or equal to character 9, for example? Well, it's because the logical AND has a lower priority than less or equal, okay? So keep rehashing, stuff that we have already seen. Hopefully it will stick around in your mind, and by the time we have an IE on that, you guys will be ready. Is there a better way? Is there an easier way, to check if a character is an uppercase, if a character is a lowercase, or whatever? Yes, and this is when we finally reach, the character class. The character class with an uppercase C, like every class name, okay, is kind of like the math class, insofar that it allows you to use some static methods that are available in it. And those static methods are supposed to help you deal with character values. So the syntax is the same. You write character dot, just like you write math dot, the name of the method. Then you put the method name here, parentheses, a parameter, and that's how you call that method. So we have a bunch of methods that come predefined for us, for our convenience, okay? IsDigit, you pass a character to that method, and it's going to return true, false. True if actually this character represents an actual digit, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? IsLetter, well, that's going to tell you if it represents an uppercase or a lowercase letter, okay? Without caring about the difference between the two. IsLetter of digit, yeah, there should be an or here. This is a typo. I cut and paste that from the slide, but I should have covered that already. So is letter or digit, no of digit, okay? This one is going to let you know, as the name implies, whether it's a letter or a digit. And then is lowercase, is uppercase, is going to let you know if it's a character in lowercase or uppercase. So we could rewrite the code from the previous slide without using, this range testing, just by using the appropriate method from the character class. And then we have 2 more methods here, 2 lowercase and 2 uppercase. those are going to translate characters. So you give to the first method two lowercase a character like ch, and I'm going to show you exactly how that looks like. Okay, so let's say, for example, I do a system. Well, I have a character here, right? Character is letter. Yeah, I have a letter here. So what if I wanted to actually not display the content of the variable letter, but I wanted to actually make sure that this letter is lowercase. So if it's lowercase, leave it unchanged. If it's uppercase, change it from lowercase a to lowercase a, uppercase a to lowercase b to uppercase b, and so on and so forth. Okay. So I would use a class character dot to lowercase, and I would pass my letter. So there we go, two lowercase, right? And I pass the value of my character. And what this method returns to me is an over character, and that over character is going to be the lowercase version of that letter. Build it, run it, let's see. And we have the weird character is lowercase a. And what if I did the opposite to uppercase? Well, you guessed it. It's going to be the other way around, right? So in this case, it was already upper. So the lower conversion happened. The upper conversion is going to look at the character, say, oh, it's already an uppercase, I don't have anything to do. And therefore, the result is uppercase A. All right? So there are a bunch of little practical methods like that. And all of the classes that I mentioned that correspond to a primitive data type also have this kind of stuff. All right? And we're going to finish here. So system.type character is returned. That's exactly what we did, true and false. Okay, so I can use those method to just detect if the character is in a certain range. All right, little bit over time, so we're going to wrap it up here. Thank you again for your patience. And we are going to transition to office hours. So I remember at the beginning of the lecture, there were some questions about course logistic. Please bring them back now so that I can clarify things for you.